Hello, in this lesson we're going to go over several different things. We're starting our chapter on quadratics. So we're going to be talking about the vertex, the axis of symmetry, and the y-intercept. And the big one is going to be the vertex. We'll spend most of our time there. The other two are fairly easy to calculate, but we're going to go through them as well. Okay, so right now we're going to work on finding the vertex. We're going to calculate it by hand. We're also going to calculate it using the calculator. Okay, so your TI Inspire is what we're going to use. It will work on a TI-84 and some other graphing calculators as well, but I'll model it using the TI Inspire, okay? And then, of course, we're going to find the axis of symmetry and the vertical intercept. Okay, let's just talk just kind of in general here. A quadratic, these are these U-shaped graphs. Some people refer to them as the smiley face or the frowny face, right? And they kind of go up in a certain direction forever, or they go down and it looks kind of like a frowny face, and it just keeps going down and down and down forever. Remember to pay attention to these arrows. These indicate that they continue to go up or continue to go down. We talked about that a little bit in our domain and range before. But okay, and today specifically we're going to talk about a vertex. So let's talk about what a vertex is. So on a smiley face graph, the one that goes up, the vertex is going to be your very, very lowest point on that graph. Okay, there is no point lower than that. It goes down, and that's right at the point where it turns and starts to go back up. And on a frowny face graph, our negative quadratic, right? We'll talk about that in just a little bit. It goes down, okay? That's our smiley face. So that's going to be the very, very highest point that it goes up to, hits that point, and then comes back down. Okay, so that's essentially what a vertex is. All right, now let's talk about an axis of symmetry. Think of the word symmetry. Think of like a human face. Most human faces are symmetrical, right? We have one eye on both sides, one ear on both sides. If we were to cut it down the middle, essentially our mouth is the same on both sides. So that's symmetrical. Now, an axis of symmetry, if we could draw a line, a vertical line that would split this parabola so that the parabola is the exact same on both sides. So that would have to go right through that vertex. So that's why we find the vertex first. After that, we can find the axis of symmetry. Okay, so our axis of symmetry, again, we'll slice it right down the middle, and it's going to be right along that vertex, okay? All right, both of those would be the axis of symmetry. All right, now let's get a little bit of, before we actually calculate how to find a vertex, we're going to need to just do a little bit of work here. Now this is the standard form of a quadratic. So this is our y equals ax squared plus bx plus c. And this a, b, and c become important whenever we get to our quadratic formula. We're going to use it right now during our vertex. So it's good just to spend a little bit of time practicing exactly what that is. Okay, so let's look at this first problem here. With this problem, I've got 2x squared plus 3x minus 5. Okay, so right here, the a value on this is the number that exists before the x squared. Okay, so the number that exists before x squared in this case is 2. So the a value on this one would be 2. Okay, so I'm going to write that over here. A equals 2. Okay, but before we do that, let's talk about b as well. So the b value is the one that's before the x. So in this case, it's going to be 3. And c is our constant, and our constant doesn't have any variables. It's just a number. In this case, it's negative 5. Okay, so let's write this down here. So a equals 2, and I'm getting that because that's the number. That's our coefficient, the number before the variable. So our coefficient of this right here is 2. Then the b would also be a coefficient because it's the number in front of a variable. So this one would be 3, and then finally we have negative 5. Okay, now you know I'm big on practice, so I'm going to give you the next problem. I'd like you to work it out. So here are your two. I'd like you to find the a, the b, and the c. If you can find those, that's going to give you a lot of practice, what we're going to need. Now, let me give you just a little bit of hint. Number 2 has a little bit of a trick. I'm going to see if we can get you on it, okay? So push pause on the video now. After you've obtained what your a, b, and c is for both of these two, come back and push play, and then we'll go through it. Okay, on this one here, this first one, hopefully you've got this one. The catch on this one, let's talk about this first one. There is no number in front of this. When there's no number in front of the x squared, that means it's 1. It's always implied to be 1. We try to write shorthand in mathematics to save some time. So anytime you see a variable with no number in front of it, it's always going to be 1. In this case, it's a negative x squared, so that would be a negative 1. Okay, so that one should be pretty good. Hopefully you got the first one. The second one, like I say, we kind of threw you for a loop just a little bit there. I've got 1 is my a value, negative 3 is my b value, and then I just don't have anything written. Well, if nothing is written, then your C value is 0. So your C value in this case should have been 0. And that's going to get important whenever we're doing our quadratic formula because we do have the C value that we're going to start using on that. So just get in the habit of at least writing down accurately what your A, B, and C is. Okay, let's get some more practice on this. I'd like you to work through these two. I'd like you to identify what your A, your B, and your C values are. Okay, push pause on the video now. Write down your A, B, and C value, then come back and push play. Okay, now both of these two got a little bit tricky because on the first one that we just did right here, there is no B value, right? It's 0 times X, so your B value is just 0, right? We don't write it. So it should be -1, and that's my A value. The B value, there is no B value there. Well, there is, it's 0. There's no X there, so that means the B value is 0. And then my constant is 4. And in this one right here, I just have an A value. My B and C are both 0. So -3 is all I need there, and the rest are 0. Okay, so now that we've got that, let's start talking itself about the formula to find the vertex. Okay, so this is our formula that we just used, okay? This ax squared plus bx plus c. We've just used that one. We're going to use it again here for finding the formula for a vertex. Okay, so this is our formula to find a vertex. This is just the x value, okay? Remember, a vertex is a very specific point on the graph. So you're going to have an x value and you're going to have a y value. So this is going to allow us to find just our x value. I'll tell you how to find the y value in just a moment. So this is -b over 2a. So you can start to see why it's important to identify your a's, your b's, and your c's. Okay, so here is, once we find our x value, we're going to plug it in to find y. That's all it's basically saying. Okay, so here is our quadratic, okay? Here's our equation. This is our graph, if you will. First thing we do is identify A, B, and C. We've got some practice with that before, so hopefully we've got that now. So A on this one should be the number in front of x squared, which is 1. The B should be the 4, and then the C is 8. Okay, so let's write that down. And I always like to write it down. I always like to go A equals this, B equals this, and C equals this. And it just helps me to keep it clear. Okay, so our formula here is -b over 2a. Okay. So let's just start plugging in stuff we know. Well, we know B is 4, and I know A is 1. So I'm just going to plug those in. Negative, and then it's 4 over 2 times 1. This is 2 times A, so 2 times 1. So -4 over 2 is -2. So I know my x value. So when I write this vertex, it's going to be an ordered pair, but I know the x value. The x value is -2. So now in order to find the y value, what I do is, well, what is my y value if x equals -2? So I'm going to take this -2 and I'm going to plug it right in here for x on both of these two. And this is where your graphing calculator really, really does a good job. The only thing I would give you for advice here is when you're plugging this one in, make sure to use parentheses. So I'm going to have this equation. I'm going to rewrite this equation. But instead of writing x, I'm going to write -2. All right, so here we go. So this is the same equation right here, but instead of writing x, I wrote -2, and it's extremely important that you have the parenthesis here. If you do not have the parenthesis, you will get the wrong answer. Because what we're doing is we're going -2 squared, so -2 times -2. Okay, if you do not have the parenthesis, you're just squaring the 2, and then you add the negative after. Anyway, just use parentheses. That will make your life a lot easier. Okay, so when we simplify this a little bit, -2 squared is 4, and then 4 times -2 is -8, plus 8. So the -8 and plus 8 cancel each other. Y, in this case, is going to equal 4. Well, I know my x value. My x value is over here, -2. And I know my y value. My y value is 4. So I know my vertex now. My vertex in this case is -2, 4. When you type it into homework, you're going to need to use parentheses, so pay attention to that. But let's make it as easy as possible. Don't write vertex equals. Just write parentheses, -2, 4, close parentheses. No spaces. Don't make it more complex than it needs to be. Okay, let's talk about the axis of symmetry. So this is going to be the vertical line right at -2, 4. That's going to divide this graph so that it's symmetrical on both sides. Okay, so if we're going to have a vertical line, we know that all vertical lines are x equals. Well, what does x equal in this case? X equals -2. Right here, we just found that one, right? My x value of my vertex is -2. So my equation of the line for the axis of symmetry would be x equals -2. So your axis of symmetry for quadratics is always going to be x equals some number, and it's going to be whatever the x value is of your vertex. Okay, so that's my axis of symmetry. Well, my y-intercept, Y-intercept, this is where it crosses the y-axis. And I know that any graph, when it crosses the y-axis, my x value is 0. So what I'm going to do is, similar to how I found my y value here, I plugged in -2. Well, I know that x value at the y-intercept is 0, so I'm just going to plug in 0. I'm going to do this same exact thing right here. I'm going to plug in 0. 0 squared is 0. Plus 4 times 0 is 0. So my y value is going to be 8. So my y-intercept in this case, that is definitely where x equals 0. My y-intercept in this case is going to be 0, 8. And when you type this into homework, you're going to need to make sure you use parentheses, and this is what it's going to be. It's a very distinct point on the graph. Okay, that is a lot of information to cover all at once. Okay, let's give you a chance to get a little practice on this, okay? So I'm giving you these next two problems. What I would like you to do, you're going to find three different things. You're going to find the vertex, the axis of symmetry, and then the y-intercept. Okay, so you're going to find all of those. Now, remember, your vertex is going to be an ordered pair. Your axis of symmetry is going to be an equation, so it's x equals some number. And then finally, your vertical intercept is going to be an ordered pair, okay? So push pause on the video now. Then I'd like you to work through these two problems. After you've obtained the answer, come back and push play. Okay, very first thing that we need to do is make sure we identify our a, b, and c values. Once we do that, we can plug it into our formula here, which is -b over 2a. That can find our 1, x equals 1. And once we've identified what x is, I just plug it back into this original equation up here. I plug 1 in for x and find out what my y value is. I find out that my y value is 5, so 1, 5. Axis of symmetry, just a reminder, it is always a vertical line, and vertical lines are always x equals some number. And it's always what, whoops, let me back up here. It's always whatever my x value here is. Okay, so in this case, it's x equals 1. That makes it nice. And then my y-intercept is always 0, some number. And it's whatever, whenever I plug in 0 for x and simplify it all, whatever it reduces down to, okay? All right, and same thing for number 2. These are both kind of very, very similar. So just check your answers there. Hopefully you got the correct answer. I'd like to give you an opportunity to get some more practice. Okay, so I'd like you to try these two. Number 1 gets just a little bit weird only because A, B, and C is a little bit different than the ones we just did, but you've already done these before, so you know how to do that. Okay, push pause on the video now. I'd like you to work through these two problems. You're going to find three things: vertex, axis of symmetry, and y-intercept. I'd like you to find all three of those for each one of these, and after you've obtained those, come back and push play. Okay. Number 1 gets just a little bit crazy because there's a lot of zeros. There's a B is 0 and C is 0. Okay, so 0 divided by any number is 0. So that makes it really kind of nice. And x is 0. Whenever I plug in 0 for x, my y value actually ends up being 0. So my vertex is 0, 0 with parentheses around it. My axis of symmetry is always x equals whatever my x value is. My x value in this case is 0. And then my y-intercept is where x equals 0. Well, that's kind of all the same thing we just did. So it's just weird that the vertex and the y-intercept are both the exact same points on the graph. It just happens to dip down and come right back up, it goes up and then turns around and goes right back down right there at that origin, 0, 0. Okay, and number 2, hopefully you're feeling a little more comfortable with those at this point. All right, so now we'd like to do a little bit of a real life scenario here. Okay, so you're going to drop this care package, and here's your formula, okay? Remember, T is the time it takes for your package to reach the ground, okay? And y represents how many feet above the ground it is. Okay, so you're going to find the vertex and describe its meaning. Okay, so I just want you to find the vertex on this one. So do your A, your B, and your C. Identify those, plug it into your formula, and find out what the vertex is, okay? All right, hopefully on this one, you're able to find that your vertex is 0, 135. Okay. So we've got that, but math, it's important to be able to do the math. But now we've got to apply this math and say, well, what is 0, 135? Okay, the easiest way to do this is I go through this and I go, well, what is my x value and what is my y value? Well, in this case, it's not really an x, it's a t, right? So t represents time in seconds. So right here when it's 0, that's 0 time in seconds. Okay, so nothing's happened yet right before it starts maybe. And then my y value right up here, y value represents 135 feet above the ground. So right before I drop this care package, I'm 135 feet above the ground, is basically what that one is saying, okay? All right. Now, we need to get just a little bit of practice here. So we're going to find this on a calculator. All right, so let's see if we can exit out here. I'm going to bring in my calculator. Let's start this. And we're gonna do the exact same thing that we've been doing, but now we're going to do it on our calculator. Okay, so let's bring some in here. We're gonna find the exact same ones we were just doing. Okay, so this is your calculator here. Okay, and when you click this button, it's just your scratch pad. So this is like if you want to just do a quick calculation, you can do that. You click it again and it brings up a graph. So I'm just going to use this one. Okay, I'm going to go up here to this one right here. Okay, on this problem here, we said that the vertex is 1, 5. So I'm going to type this one in exactly like I see it here. Okay, so I'm going to go negative 3x, and my squared button is right here. And then if I key with the squared button, it makes it really, really nice because I don't have to worry about anything else. Then I go, okay, then what we're going to do is we're going to go plus 6x plus 2. Okay, again, I'm doing this one right here. Now, when I hit enter here, it's going to graph it. There's my graph. Perfect. Okay, now I have to find the vertex on this one. Okay, well, if you're using a TI Inspire, it's going to be very, very easy. Okay, it really kind of makes it nice. Okay, what we're going to do here is we're going to hit menu, and let's see here. We're going to go analyze graph, and let's look at which one I'm looking for. So let's escape out of that. Escape out of that. On this one, I'm going to look for the maximum point because it's an upside down parabola, right? This is our frowny face, and the vertex is going to be the highest point right here. I'm just going to move this guy a little bit out of the way here. That's just the equation. Okay, so the very highest point, I'm looking for the maximum. So I'm going to go menu, analyze graph, maximum. Okay, so I'm looking for the absolute maximum point, and you can see my cursor right here. Here's what you do. You click anywhere on one side, and it doesn't matter which side you choose. So I'm just going to click anywhere here, click. And what this is going to do is I drag this across. It's going to find whatever the maximum point is. So if you notice right here, my maximum's constantly moving because as I move, it's going up. And then all of a sudden, boop, here's my maximum. Boop, I found it, okay? Right there. No matter how far I go over, that's my maximum. Okay, so right there is my point. I'm going to move this up just to make it just a little bit easier to see. That is my vertex, 1, 5. There you go, 1, 5. So you don't actually have to do the formula and calculate it every time. If you have your calculator, you can do that. That will work just fine. Okay, I'm going to do, let's do the one right next to it here, just to give you a little more practice there. Okay, so I'm going to use my tab. I'm going to go up, and I'm going to delete this one. Okay, now this equation right here is x squared minus 6x plus 8. So I'm going to go x squared minus 6x plus 8. Okay, I'm going to graph that one. There we go. That's what this graph looks like. Well, on this one, instead of looking for the maximum, it's a smiley face. So I'm going to look for the very, very minimum. Remember, our vertex, if it's a smiley face, if it's going upward, is going to be the lowest point. So again, I go menu, analyze graph, and this time I'm looking for the minimum. And just to let you could normally I start on this side and go this way, but it doesn't really matter. I'm going to start on this side, and I'm going to drag it in this direction. And you notice how it always finds the minimum point, whatever my minimum point is, until I go boop, till I found it. Boop. Now, yours doesn't make that sound, but you get the feeling. Right? And right here, it says it's -3, -1. Okay, so let's double check that I've got that formula in there correctly. I don't. I have positive 6x. That's what's throwing me off. Okay, so I needed to hit -6x. Okay, so new formula here. And I'm going to go again, menu, analyze graph, minimum. Here we go. Boom, right there. 3, -1. And that's what we found when we did it by hand. So they're both the same. Either way that you want to do this is going to be absolutely fine. There's going to be nothing wrong with that. Okay, so let's just get a little bit more practice here. We're going back to our PowerPoint. We're going to go back to the slide. I'm going to get some more practice on real life problems here. Okay, so here we go. Katniss is shooting an arrow, right? So she's standing here and she's going to shoot the arrow and it's going to go high in the sky. And here is our formula. And you always just want to really pay attention to what h of t is, because it tells you right here, represents the height in feet above the ground. And then t is the seconds, however many seconds it is. So here's your formula. So what we're going to ask you to do here is determine the practical meaning of the vertex. Remember, she's shooting it. What kind of graph does this look like? Is it a smiley face? Is it a frowny face? Let's find the vertex and we'll do the practical meaning. So the very first thing we have to do is find the vertex. So we're going to graph this one. And it's going to look like this. The vertex is going to be the very, very highest point on this graph, okay? And the vertex, if we're plugging it into our formula or you're plugging it into your calculator, either one doesn't really matter. You end up with 3, 149. Okay, and we go back to that original problem, and I find out, well, what does my x value equal and what does my y value equal? Well, in this case, t equals number in seconds. Okay, so t is my x, 3 seconds. H of t, that's my y, right? That's my output, is 149, and that represented the feet above the ground. So this basically means after 3 seconds, this arrow is 149 feet above the ground. Okay, that's very specific to that point. There's a little bit more to that. After 3 seconds, it reached a maximum height because at 3 seconds, it's turned and started going down because we have gravity. So that arrow is going to turn and then start heading toward the ground. Okay, so at 3 seconds, it reached a maximum height of 149 feet. All right. So what's the significance of the vertical intercept? Well, the vertical intercept, that's where our x value is equal to 0. So we just plug in 0 for x. Right? If we were to graph it, it's right here, 0, 5. Okay, well, what does that mean? 0 is time in seconds, so at 0 seconds, it's 5 feet above the ground. What does that mean? At 0 seconds, it's 5 feet. Well, that's right before it was shot because it hasn't actually left her bow. So if you just envision someone getting ready to shoot it, she's shooting it from 5 feet above the ground. Okay, that is the launch point, if you will. Okay, at 0 seconds, it's 5 feet above the ground. The arrow was shot from 5 feet above the ground. All right. So let's talk about domain and range of this one. The domain and range of this function is different than the practical domain and range. The practical domain and range on this one is a real life, right? She's shooting it all the way until it hits the ground. Once it hits the ground, the arrow is not continuing on. It's not going to go through this ground and keep going, right? I mean, that arrow is going to hit the ground and stop. So you're going to have a very practical domain and range. So let's talk about that right now. The domain on this one, the practical domain, these are our x values. It starts at 0, okay? And this is, remember that the x values are our time in seconds, and it goes all the way into 6.5, and at that point it stops. So that means the arrow is in the air for a total of 6 seconds, 6.05 seconds, okay? The range on this one, the y values, well, it starts at 5, goes up to 149, so we definitely know it's 5 to 149 at least. And then it comes all the way back down and hits the ground. So then it goes all the way back down to 0. So it's actually going to be 0 to 149 is going to be our range on this one. And that's a little bit different than just the graph. If I just gave you this graph and said, what's your domain and range, it would be vastly different, right? Because it would continue on past this x-axis and continue on. But in real life, it doesn't because it hits the ground, okay? And it was shot from 5 feet and goes all the way to the ground. You're not going any more than that. All right. So this is our last one that I want you to try to work through here just a little bit. And this is a real-life domain and real-life vertex on this one. So I want you to find the practical meaning of this vertex. And it's the same type of thing that we just did. So I want you to push pause on the video now. I want you to find the vertex, and then I want you to explain the practical meaning on this. Okay. All right. Hopefully you had some success here. I'm excited. Okay, so this is your vertex here. And I did say round it to the nearest hundred, so that's 2 decimals. I do that a lot in online as well, so just pay attention to the decimals. And this one's basically the same thing. T represents the time in seconds, and h of t represents the height of the ball. So after 2.19 seconds, the ball reaches 80.56. Let's see, this is feet. Okay, or you can say after 2.19 seconds, it reached a maximum height of 80.56. Okay, so this concludes this video. I hope you found it helpful. Please let me know if you have any questions. I'll also post individual examples on your homework as well.